Hello, everybody. My name is Tess Konovich, and I'm the Scientific Marketing Manager here at EarthShift Global. It's my absolute pleasure today to introduce Rafael Oras, who is a professor and the Amcor Endowed Chair in Packaging Sustainability at Michigan State University's School of Packaging. He leads a multidisciplinary research group of undergraduate, graduate, and postdoctoral students dedicated to advancing sustainable packaging through studies on mass transfer in polymers, biodegradable materials, life cycle assessment, and the design of circular packaging systems. Please feel free to use the question and answer feature at the bottom, and we'll go through all of your questions at the end of this session. So welcome, Rafael. I'm excited for you to get started.
Thank you, Tess. I hope that everybody can hear me okay over there. It's a pleasure to be here and to be in this Brown Bag webinar seminar. We have a very long relation with EarthShift, working in the area of life cycle thinking and environmental trade-off assessment. So I would like to talk a little about that today, but I also would like to tell you, before I start, a little about the School of Packaging for the ones that are out there and don't know where we are and what we do. So for the ones out there, so we are here in East Lansing in the state of Michigan. This is the MSU campus, the map, and in the middle of the campus here, there is a School of Packaging. And yes, there is a School of Packaging where we do study packaging, and we have been here since 1952. The next year we will celebrate our 75 years. And we went to a large transformation to many different periods, working with different stakeholder, industry, government. But through that process, since we started in very small building, what we are today, so we have a renovation 1982, a latest renovation that happened during the period, the COVID period. And now we are moving to a second phase of the school, on the back of the school, where we're expanding our research capability. So since we started at MSU, we have been a program that been growing since that time. Right now, we're ranking #1 program in the US. 40% of the packaging students or packaging professionals in the industry right now are coming from MSU. If you come to MSU, you can have a bachelor in packaging. You can continue to have your master, and you can also go to get your PhD. So you can spend almost 10 years of your life with us and have all your packaging degree and knowledge that you want at the School of Packaging. So we are a large family, so around 600 undergraduate and graduate students plus the faculty. So around 520 undergraduate students, around 30 PhD students, and the other master students online on campus. We have already conferred more than 10,000 degrees in the beginnings that we start. So chances are, if you are in the US or around the world, that you will meet an Spartan and somebody is working in the school in packaging, chances that will have a degree from us. So, and that makes us a big family around the world that allow us to not only know about packaging, but also to try to move the scholarship and the research and the teaching of packaging. We are also highly involved in research. That's one of our core mission: research, teaching, and outreach. And as one example of this involvement in research, we just have a NSF center, IUCRC center, that is to move sustainable innovation in the plastic and paper and hard materials domain. So if you're interested in that, please don't hesitate to contact us. This is a nice collaboration between the School of Packaging at Michigan State University and Western Michigan University. This is the team of the school, the faculty, plus we have all the students. I am here, so I conduct research, as Tess say, in 3 different areas: the area of developing of packaging structure with tailored properties, end-of-life scenario, a lot of work done in the area of biodegradation. And today we'll concentrate in the part of life cycle assessment and how we use life cycle assessment for decision making. And now that things are moving along globally and in the US, how we use in life cycle assessment for a decision making process. So let's get into a little more into the discussion of life cycle assessment in packaging and where we're going with the research in life cycle assessment and what are the concerns and what things do we need to solve and what we have been doing. So as you know, the packaging industry is often looked as an unsustainable. So we have this relation. I always talk that the consumers has a relation. They love to get the product. They love to get the product with the package. They love the use phase, but they hate the end of life. And that create a relation that we in packaging that then we need, when we assess that, we tend to emphasize some of the stages more of the packaging system than other. But in general, what happened that this packaging decision process, now what happened there, are not generally used for science-based information, no, because at different stages that we have in the packaging supply chains and the product, where the environmental footprint of those packages and products will have larger contribution than other stages. So it's very important that we can use science-based information to make the decision. And LCA can actually help you to do that, but it's very important that we use that LCAs to look at a holistic approach, and we try to do to look at the different phases. So, and this is very important now, as globally we're moving in different directions. So that, as you know, globally we're moving in legislation around the world, and the US are looking at a packaging minimization or reduction or in unnecessary packaging. We're looking at circularity, sorry, that not only recycling at the end of life, but also post-consumer recycling content, introduction in the materials. And we also are trying to avoid with that regulation that we don't have leakage into the environment. This is in many different cases for single-use packaging that become a concern. And when we need to report the scope 1 to scope 3 in the packaging industry, also we are looking at how we can use our data from our assessment to do that reporting for the packaging component in general related to the scope 3. But now with all this regulation and all this legislation moving around the world, the question is, are we moving in the right direction? No? Are we actually trying to use that data to make the decision and to try to understand how to properly implement packaging system with the lowest environmental footprint? So, and the thing that happened with the current regulations, they mainly concentrate on the packaging, and they forget the role while the packaging is there. Not so we have a package to protect the product, not to distribute the product and to actually to consume the product. So and then we forget that the role of that, and we try to regulate just onto the end of life of that package, and that creates an issue in trying to look at packaging as a holistic approach in order to reduce the environmental footprint or even the different indicators that we're interested to look in LCA. So with that, LCA can help you on that. But the thing is, what happened with that is that the consumer and the companies in general tend to be a little confused about what is important and how to look at that. No, and I will provide an example of that, a work that we did a couple of years for one Michigan company that was interested on providing or provide infant formula to the consumer. And they have a requirement of one of the retailers that they want to have more infant formula on metal can in this format on the right, and they distribute this in three different formats. So the question here was, if you actually want to distribute that and you want to distribute the infant formula, which one will deliver with the lowest environmental footprint? The retailers actually push to have a material with larger recycling content. Again, looking at the end-of-life scenario, looking at post-consumer recycling content, and looking which one will deliver the assumption that will deliver with the lowest environmental footprint. So the good thing with this study, we have all this primary data that we work with the company. So the company would provide all the configuration, the supply chains, all the materials that we need there. And with that, we could run a very interesting study that will look at in each one of those packages. The functional unit here, we're delivering 1,000 grams of infant formula, and then in any classic study, you will have your contribution. You see here, you have the life cycle contribution analysis. These are 5 indicators where you have the assembly of the primary, the disposal of the primary in these categories, and then you have the secondary and the tertiary contribution that in generally in any packaging system, they tend to be smaller than the primary. And then when you look at this and we look at the trade-off of this and we look at the comparison for the different containers, you can see that, and this is very common to see, you'll see that there's a trade-off between the indicators. You see package 1 here, this plastic can with a barrier layer has a higher impact indicator in fossil fuel depletion, ozone depletion, global warming, and electrification, and it has lower in respiratory effect, ecotoxicity, non carcinogenic, and smoke. And then you look at package 2, has the largest smoke acidification, intermediate values there for the other indicators. Package 3 has largest in ecotoxicity, respiratory effects, non carcinogenics, and carcinogenics. And then almost the same in these indicators. So when you look at this, the situation that happened here is, okay, so what is important for me? What is my trade-off? And if you are using only one indicator here, you may do one decision, but you use another indicator, you may do another decision. And if you look at other indicators, the decision is different. And not only that, if you actually consider different ways where you allocate the end-of-life scenario, in this case, what I'm showing here, this is the cutoff methodology where you actually, whatever you're sending to recycling, you're not penalized for that. Whatever is going to landfill or incineration, you're being penalized for those emissions. But if you actually using other type of allocation at the end of life scenario that you're using a 50-50, for example, or you're using the circular footprint formula that is using the European Union, you may reach a different type of conclusion. So we did that different type of scenarios. So this is the cutoff that I showed recently. This is the 50-50 when you are the material that you send to recycle, you pay the 50% of the emissions of the recycling that material, and the 50% is for the second user there. As you remember, the cutoff will be the one that using is actually paying for those emissions, but not for the virgin material. And then you have the circular footprint formula that is a little more complex than that has a methodology where you also get credits. But you see, for example, here that the package 1 has the fossil fuel depletion and larger, but the other indicators are being reduced because the energy credits that you get for burning those materials. But so you look at this and you still have a decision. What is the decision making that I made for those containers? No? And then when we got into that, we were looking at working with the company. And at that time, we were working also, been working for a long time with Earthshift Global, also with Liz Loring. And she introduced us to a methodology that is very useful in packaging. And that was developing at Arizona State, that is looking at this stochastic multi-attribute analysis, where you actually can look at the indicators. You run the uncertainty, you run a Monte Carlo uncertainty, not always done in the studies, but you run a Monte Carlo uncertainty, you use that data, and then with that data, you actually can run another uncertainty in order, depend the way that you have for the indicators, and to try to run which package will have the lowest environmental footprint and which one has the largest environmental footprint. So in this case, you are seeing the probability of ranking for a package 1, package 2, and package 3. And when you look at that, you see that the different, how you rank that, rank 1 that has the lowest probability to have the lowest environmental footprint, and then the 2 has the middle, and the 3rd has the large. So we actually run those scenarios for the 3 of them, and we run for the different actually type of allocation methods that you look at the end of life scenario for those. And in all these scenarios that you run, and you run the different probabilities in which one has the lowest environmental footprint. See, if you look at the package 1, where you use the cutoff methodology, you can see that a package 1 here has the rank first to have the lowest environmental footprint. Package 3 rank last. When you do the 50-50, you have package 1 rank first, or may rank last to have the the highest environmental footprint. And when you do the circular footprint formula, again, package 1 run that has the lowest, and package 3 run that has the largest environmental footprint. So when you do this and you actually start looking at doing this allocation, then you can see that you can now have a decision process where you look at those packages and you can move forward and say with the methodology that when you actually run the study, the important part here that we all have the primary data of the supplier and the company. So then we are based our data on the actual supply chains of those packages in the market. And then when you have the data, run the uncertainty, and then run the SMAA method, you can actually state that the package 1, in this case, will have the highest chance to have the lowest environmental footprint in the supply chain. Package 3 will have the highest chance to have the highest environmental footprint in the supply chain. And then package 2, we run a number of scenarios. This is a composite CAM. We actually change the metal button with a paper or composite fiber-based button, and then the ranking actually starts changing. But that's part of the scenario analysis that we did. But with this information now, the company can go to the retailer or to the supplier, whoever is buying those containers, not those with the infant formula, and you can say, well, you want to have more metal can, that is okay, but if you actually want to make a decision there, according to our supply chains, we can stay the package 1 will lowest the infant formula to the consumers with the lowest environmental footprint. So, and that is a nice story and a nice process that you can use for decision process, no? Because we are very concentrated at this stage on looking at the package and the end of life scenario and forgetting the function of the package. So that was a nice journey. This is science-based data that you can use to move your decision process and actually understand what is your scope 3 reporting and how it will be the data for your supply chain. But then if we take a step further and we start now looking at the package before versus the product, and in this case I will use the container with the highest environmental footprint, that is the infant formula in the Metacam. And if you look at that, no, you can see that in this case, the green olive color here is the contribution of the metal container. No, this is actually the metal silicon. In two indicators, you have that the carcinogenic and non-carcinogenic that are larger. But then when you're looking at the 1 kilogram milk powder, you see that in this case, the milk powder has a much larger contribution than the container, no? And these are containers with a high environmental footprint. And this is not surprising, no? This is not surprising that you will see that, and you will see that those containers will have the largest environmental footprint, no? That is, the milk will have the largest environmental footprint. And here there are these two indicators that they have that you need to be concerned. And many years ago, we were also doing another study with milk and find also the same situation, no? The same situation, no? And I think that's the thing that I want to bring today. When you have this situation and you look at the environmental footprint of the product and the package, so sometimes you need to look at the whole supply chain in order to decide where you will actually do the reduction. Because in this case, if the milk formula has so much of the contribution, any loss that is having the container due to the infant formula there, then you actually maybe fully change any difference that you do with the package. So as I said, many years ago, we did a study with colleagues in Arkansas and looking at in-home containers and on-the-go containers for milk delivery. And in this case, if you actually look, this is the 1 gallon container, the one that we have at home, the regular one that we put in our freezers, in our refrigerator, sorry. And these are on the go. But if you look at that and you look at the supply chains and the production of the milk container and the distribution, the same thing happened here. So you have the situation that in this case, you have other indicators, a number of them, climate change, commodity energy demand, freshwater depletion, all the way to ecotoxicity. And you see what you expected, no? That the milk here, no, the milk has the largest environmental footprint. of all those indicators. It's what you expected. Now you have a packaging system to protect the product, which has the largest environmental footprint. The second largest indicator in most, the second largest contributor and most of the indicator is the consumption phase. So you see here the consumption phase in climate change, container energy demand, and photochemical oxidation, and ecosystem. Ecosystem is the second one largest. And if you look at the container here in cumulative energy demand and climate change, you see that you can see the contribution. In others, you don't see almost any contribution because it's very small. So, and that's very, very important and relevant for decision making, because if you look at this and say, well, anything that I can reduce here, I can actually maybe reduce all the total emissions. And that actually put us in a journey to try to look at this information and try to see if we can make the decision based on the supply chain. So what we did there, so we got the supply chains, and you see in supply chains it's very common that you have the different type of losses that happen at the pre-supply chain, before the consumer and after the consumer, and we try to model there what happened in that supply chains. And you look at a milk account more or less for 13% of the total waste in the US. And if you actually look at how much that amount, that is a very large amount, 4.76 billion kilograms of milk, and if you actually multiply that by the amount of CO2 that 1 kilogram of milk, to produce a 1 kilogram of milk and to deliver to the consumer, you have a very large emission there, and that is not small contribution to the environment. So you have a contribution here of greenhouse emissions of around 1,270,000 homes emissions. That is the same emissions that the house will produce, or the annual energy. So, but the problem with this is that LCA as a tool is very linear how you do it, and when you need to do action or a consumer-oriented type of decision process, you need to integrate the LCA and the environmental footprint with other kind of process. And this was done similar to the things that if you try to image what happened with the consumption, it's very similar what happened when you're trying to model the on-time departure and landing of plane. No, you actually, an action start, so a plane come to the airport and landed, and then that action stop. Then another plane will take off, and you you optimize that. So you optimize for the landing, and so your runway is always optimized for how many planes you can land and how many planes can take off. So the same thing happened with the process that you want to model here for milk consumption, because what happened is that the consumer will buy the milk, it will actually take to the home, it will actually put in the refrigerator, and then use it for breakfast or for consumption or for drinking, and then it will put it back, so you will consume. So then we did that model, and we tried to model using a discrete event simulation that allow you to do that process, where you actually have based on the events that happen, not the actions are treated as entities, so then you can move queues in that process. And with that, I try to model the consumers, and we try to model the consumers in the US based on different categories. And this is based on the US Census. So we actually got different consumers there. We have the one no family member home. That is the number of people there. You have 32 million people living in that situation. And that was in around 2018, I think, data that we used it. And two no family members home, is much smaller, that number of houses. And then 4 family home, where you have 15 million people. This actually, we have 2 adults and 2 children. And the regular consumption of those populations here, what you have is that the one no family member home will, if they buy 1/2 gallon, they will per year, they will have all that greenhouse gas emission. So this is 10 to the 9, so it's a very large number. Then 2 no family member home, they will buy 1 gallon, and here this is all the total emissions. And the 4 family home will buy 2 gallons containers every week. So then you have here the green is the consumption, this is the amount of milk consumed. The pink is the amount of milk spoiled. So there was no consumed. This is the amount of the containers here that you are actually emission the containers, and the containers with milk that you are disposing there. And then you have a small modeling here that you're trying to do this top-up shop that you actually go to the gas station maybe to buy when you run out of milk. So if you look at that, we then run these scenarios and trying to say, well, what will happen if they will buy the one no family member home will buy 2 quarters, and the 2 no family members home will buy 2 half-gallon, no 1 gallon, and the 4 family home will buy 4 half-gallon, no? And you see that here, in this case, we don't have a reduction here, we have an increase, and there is a little of reduction on the amount of milk waste, but then you have an increase on the amount of container use, so then you have more waste there. The 2 no family home, there's very little variation, and in the 4 family member home, the values there, the variation that you have there is not as large. So, but if you try to optimize this, we went ahead, and the 2 no family member home, we couldn't do much optimization. So the 2 half-gallon produce little amount of spoiled milk, and the consumption increase, the available consumption, and we cannot do more optimization than that in that scenario. But for the 1 no family member home, if they actually do not buy the 1 half-gallon, but they buy the 1 quarter, they have almost enough milk to meet the requirements of the milk that they need to consume. The amount of waste milk changed a lot. And there is a little more that they need to do in this top-up shop. But then when you look at the 4 family home, in this case, if they don't buy the 2 gallons containers, but they actually buy 3 half-gallon containers, no, this family home has much more milk available during the year. The waste that they generate actually is much smaller, no, because of the delay of opening the container, no, when they get spoiled. And then you may have the containers that you use there is a little more, but your total emissions of greenhouse emission as the population in the US is actually being reduced. And that's important when we start to making decisions now, and we try to do decisions now for the EPR system, and we try to look at what happened in the different states. This is the numbers that we want to keep. Now, what are the decision process that I will do in order to reduce the environmental footprint of the greenhouse gas emissions, of the indicators that I'm interested in my regulation, to reduce overall those emissions. In this case, we are changing from buying these 2 gallon containers to buying 3 half-gallon containers, maybe increasing the amount of package, but the total emissions that are changing. And that actually came us a couple of years ago to another study that was looking as regulation changed globally. No, we have this regulation that is being changed with the packaging provision that we talked before. You have recycling requirements, you have recycling content requirements, you have EPR requirements. The US is going to the transformation. California, Oregon, Colorado, all of them are actually getting the EPR system and requirements. And you have reuse and refill requirements. How you actually go about to use this information and start making sense. And I will provide you one more paper that we actually published, I think will be almost 2 years ago now, where we look at all the studies between 2010 to 2023 that look at the different system to deliver products in multi-component metal, plastic, carton, paper, and glass. And we look at in the North America and Europe, and all the studies published in English. So we actually did a meta-analysis of those numbers. So that means you actually get all the numbers for every study. You look at the numbers that you want to report. In generally, you will have numbers for greenhouse gas emissions, and you will have numbers for non-renewable energy or non-renewable resources or fossil fuel use. But other indicators, it's very hard to get a meta-analysis on them. But we actually got all this data, and then after crunching this data, we have all the distribution. This is a kind of complicated diagram, but it's very simple to understand. Here you have the containers in this size. there is the materials that is in the middle, and then on the other side you have what you are delivering. No, and this is more or less to look at the domain of the studies. But the important thing that we got here, and it was interesting to look at, is if you want to deliver 1 liter of product or 1 gallon of product, in this case, you have that this multi-component aseptic carton, the rigid cap, the flexible pouches, the rigid plastic, and this rigid bottle plastic Europe, they all deliver this product, this 1 liter of product with the same greenhouse gas emissions indicator. We can discuss about the other indicators, but as I say, not everything is reported. But when you look at that, they all deliver this with the same greenhouse gas emissions. So there is no difference there. There is an emission. There is different than when you consider the North America that we use little heavy bottle for some of those for those studies that are reported. Of course, you have different for metal and you have different for glass. So then, if you want to deliver and you are looking at this, you can see that all these containers here are delivering 1 liter product with no statistical significant difference in greenhouse gas emission. The same thing happens when we're looking at 1 kilogram of product. No, we have aseptic carton, pouches, and bottle, and all of them deliver that 1 kilogram of product with the same greenhouse gas emission. There's no statistical significant difference there. The rigid boxes here were actually lower, and the metal can is much larger. So then this is important because now we start trying to regulate this and try to look at the system, all the EPR system, and looking at the end of life scenario. And what we may need to propose here is other type of concept and other type of things that may be much more relevant and interesting that we address. No, and we need to start thinking about this ratio between the environmental footprint of the product and the package, and then when actually there is very beneficial to use some type of this eco-modulation or eco-design aspects that we want to use to reduce the total environmental footprint of decarbonize our supply chain. So, for example, if you have a large ratio of the contribution of the package with respect to the product, so or compared to the other type of ratio that you have, for example, in this case you have spinach, and the topic here you have cheese. Again, this is a kilogram of CO2 equivalent, the ratio between the product and the package. Yeah, and you see that for product with lower environmental footprint or greenhouse gas emission in this case, you see that the ratio between those two, you see that a contribution of a change or introduction of recycled material here, it does create a large benefit on that reduction. But in the other case here, no, when you have this ratio, no, like virgin PET bag, PS tray with an overwrap, anything that you can do to reduce any losses that you have here on the product, it will actually create a large advantage, even if you actually increase the contribution here of the package, because the environmental footprint of those materials here or this product here are much more larger than the other product. So I think that we covered a lot, and I think I would like to allow some time for questions. But what I want to try to provide with this short seminar today is that the LCA allow us to have this comprehensive evaluation of the environmental footprint and of the product and packaging system. That this is something that we should not forget, that we put the package to deliver a product and to have a function. So then we need to look at them as a holistic system to try to assess that environmental footprint. It allows us to estimate the environmental footprint trade-off of those packaging system and do comparison if we want. And maybe we can do trade-off now with product packaging system and understand that trade-off. That is a little more challenge, but also much more insightful, because if we want to decarbonize the supply chains, looking at only the end of life scenario will not provide enough insight to do that job. And also, the project that I showed you that we did for these 3 containers, we also did other projects to inform design, where you can look at material substitution or other type of design instruments that you can have to reduce the environmental footprint of those packaging systems that we are using. No, again, when I talk about packaging system, I talk about the primary, the secondary, and the tertiary. No, but we still have a lot of work to do. We still need to create a fair and transparent environmental assessment method to capture these full product and packaging impacts that will include the waste, the loss rate, and the user behavior, and that we still don't have that. In general, we tend to use tools that in many cases only are using the package and not including the product and the package. And the loss rate, that's something that we're missing to make this decision and to make sure that we are considering functional equivalent packaging system. We also have a large need for collect and analyze data and this packaging function and the use across region, because it's not the same when we have North America, when we have Europe, or when we are talking about South America, we talk Africa or Asia. So there may be some indicators that we're using there for the LCA area of protection that are relevant for those studies may be changed because how the systems are implemented in those areas and also for decision making. And in order to create this win-win strategy for the consumers and for the industry stakeholder, we need to make sure that we include this waste and waste loss in the supply chains completely in order to, if we want to decarbonize the supply chain. With that, happy to answer any question. Go green. And let me know if we have enough time for answer some of the questions that you may have.
Thank you. That was incredible. I learned a lot, and I have received a few questions both in my chat and we have one in the Q&A as well. So please enter any questions you have in the Q&A box, and we'll start with the first one. So the first question is, using science-based information to make decisions to lower emissions doesn't always translate to consumers understanding that it's being done. How do you recommend brands communicate about their packaging decision-making processes to consumers?
I think that, thank you, Elisa. That's a great question. I think that there is not only the consumers. I think that the consumers are very important, but sometimes we put too much pressure that the consumers should understand and they should making decisions based on all this information. And it's very hard, even for us that we are in the field, to understand all this data and make sense of the data is hard. But I think that the first one that need to understand are the policymakers. So the policymakers are the ones that need to have that information. And when they have that information, they can create policies that incentivize consumption and production with lowest environmental footprint. So then if those policies and those incentives are in place, then brand owners has a much easier pathway to communicate to the consumer the decision making and the process that they do. Right now, I think that we are going to a process where there is a mixed bag of things going on in material substitution that we're doing, that we don't understanding if that will create a boomerang effect or rebound effect on in some of our emissions. And I think that it's important that we as a professional, as association, communicate to the policymakers, so then the policy that are creating the different state on the different regions of the world are actually created to incentivize this reduction or decarbonization of our supply chains. With that, then we can then make the consumer to make the best decision, and the brand may have the tools to incentivize that consumption. But I think that right now the landscape is very complicated and we tend to go to different directions. I may not answer all that question there, but thank you. I think that there's a lot that need to be done, and not only at the consumer level.
Thank you. Our next question is, when you consider food waste in the model, how should it be quantified and modeled? Is it an estimated percentage of the resources required to produce the food itself?
So that is a very good question, because we're looking at we struggle a lot to model proper losses in the supply chains and consumption. So for that, we actually moved to discrete event simulation to try to quantify those models, those consumption. And not only us, I think the RAP in the UK also, the RAP project in the UK also used discrete event simulation, and there is a number more of studies going that way. But what we are doing is, the consideration is that to deliver your functional unit in your studies, you want to deliver any product, in particular 1 pound of that product, you will have an excess of production in your supply chains. But that excess of production waste is not happening all at the at the gate of the farm. It happening all the way to your supply chain. So it's not the same, the percentage of waste that you have in the process. You may have emissions that happen at the gate, and that are emissions that are closer to the consumption where they was already distributed in your supply chains. Let's imagine you have tomatoes and you're distributing tomatoes in the US supply chains. They will come from California, they will come from Florida, they can come from Mexico. If you are in Michigan, it may come also from Canada. The waste creation in that supply chains is a little different, and where you allocate that. So you need to have the knowledge, and we're trying to get that inside in the supply chains. And for that, I think that it's very important that we start moving there, and we just not doing a comparison of just this A versus B without understanding all that different geographical boundary that you have in the supply chains and when that waste is being created. So I don't know if I answered that question, but there is a lot of subtleties in counting waste because waste is not always the same.
Thank you.
Yeah.
So this next question we have, first, this questioner said, very insightful and great session indeed. So I want to give the credit there where it's due, Rafael. And the next question is, do you provide a certificate of participation from this webinar? So at Earthshift, we don't, but Rafael, I thought maybe it might be a nice time to plug any certificates or packaging courses you do offer.
Yeah, so for this webinar, we done. So I think Earthshift maybe want to think about doing that in the future. At the School of Packaging, we have a number of opportunity for different type of degrees. You can have bachelor's, you can have lifelong education. We have short courses for industry. We have a full master on campus and a full master online for professionals where they're working professionals. So you can actually think about if you're in a company and you want to learn about using streamlined LCA tools or a full LCA tools, you can enroll in that type of classes that will help you to do this type of assessment that we do for a decision-making process.
And at Earthshift, we have a number of training programs, and we're actually working now to revamp that page and offer on-demand courses and possibly certificate programs in the future. So definitely stay tuned for that. But for now, this specific webinar, although very insightful and I learned a lot, we don't have a certificate for. Okay, I have a few more questions. Again, we have time, so feel free to add any to the Q&A. But one question here is, how critical is high quality primary data for LCA trade-off assessments, and which data gaps most skew results?
Yeah, let me see if I can change. This is changing now. Not changing. Okay, so in the example that I show here, in this example that you have with the 3 containers, we were able to do that assessment and provide the information to the company because we have the primary data of where those containers were produced in the North America, where the material came from, what is the energy used for that. So that is very important. And so then the decision making that you will do there when you actually want to do a comparison here, and you say, well, if I run a comparison of these containers and looking at which container has the lowest environmental footprint there based on the ranking, you can actually do that based on the way that you have your primary data. So that's very relevant. If not, we do a lot of these studies that are based on assumptions, and they're interesting, they can be informative, but the problem is that we want to get conclusions to make decisions in the different places, and that is becoming a challenge because you have this no primary data. So primary data is a must, and it would be nice that we have much more primary data reported. When does it make it more important? Well, when you have the larger contribution, does make it much more important. No, if you actually have your primary container and you don't have very good data, your primary container, and you assume the materials that are there, and you don't have the right contribution of that, that will make a very large impact on your decision process. Also, if you want to assess product packaging, if you don't have that, also in this case, if you don't have the right data, to do the contribution, no, then you also will have a large different conclusions. And when you actually want to move this data, not only from the package, but when you want to move this data, not from there, but you want to move the data to the whole supply chain, no, when you want to move here your data, and this is like when you want to talk about the supply chain and make decision on the supply chain, if you have there, imagine that if I have a 10% uncertainty, maybe this or 20% uncertainty in this data, these data will not be different. I will not be able to make a conclusion there.
Thank you. Two more questions.
Mhm.
So the first of those two are EPR policies often fixate on end of life. What upstream impacts and key trade-offs are we overlooking by doing so?
Yeah, so this is okay. Thank you for that question. If you have loss rate, no? If we have this system here, and you have this loss rate, and you have different packages that they do not provide the same functionality, no? This in this case, when I open the whole gallon of milk, the whole milk actually is exposed. I have more or less 7 days to use that milk. In the other case, if I have my containers here, I don't buy 1 gallon of milk, but I buy these 2 gallons, two half gallons, no? Then I delay the opening of the second gallon of milk, and I have the shelf life that is much larger. So less milk will go to spoil. So it's very important that when we look at that when you look at EPR, look at the functional equivalent of those packaging systems, not just looking at the end of life scenario and try to use that information, because maybe on the supply chain, the amount of waste creation by different packaging format, it may be actually lower, even though that you are buying more package or you have more emission. In this case, as I showed before, in the case of this slide, where you have maybe more emission here, or a component of the package that you are buying there, but your total overall emissions are lower.
Thank you. And our last question, where can we access the stochastic multi-attribute analysis or SMAA methodology that you spoke about earlier?
Yeah, so there are a number of papers. So the papers that we have here was based on a paper from Valentina Prado and from Liz Loring that was done before. So you can actually send an email to Liz. I know that Airship has some of those models done in the software that they're utilizing now. You can access this paper, and it will have you some information on how to do it. And feel free to send me an email. We're happy to send you the links of these papers, and I think they are all open source, so you can download those papers to introduce yourself to the stochastic modeling, multi-attribute analysis modeling, and see to look at that trade-off.
Well, thank you. And also feel free to email us as well, or me. Like Rafael said, we have a number of resources that discuss SMAA and also our Matter PD software tool. But thank you, Rafael, for such a great talk. I really enjoyed it. And thank you, everyone, for engaging so much with all of the questions we had. But thank you all for attending today.
Yes.
Thank you, especially Rafael. And hopefully we'll see you all at next month's webinar, which we'll be announcing soon.
Thank you. Have a nice afternoon, everybody. Bye for now.
Bye.